In this video, we're learning about nCr. It's a very fancy way to pick objects and do like arrangements, but without regards to ordering. That's the sort of important thing compared to the last topic of permutations. So first of all, I just need to show you how to do the formula. There it is. It's got a bunch of factorials in it. It's very fun. But C53 would be 5 factorial over the top and 3 factorial over the bottom. And you've got to times it by 2 factorial as well. So essentially, this here was the 5 factorial, that was the 3 factorial, and then it was 5 take 3, so it was 2 factorial on the bottom. Quick way to know you've done it right is the bottom 2 numbers should add up to 5. Now, this would normally be really awful to calculate because it's a whole bunch of tricky multiplications, but usually they simplify quite nicely because that cancels out with that. And if you want to be extra fancy, the 4 can cancel out with the 2, and you would just get a 2 instead of a 4 there. Anyway, the answer is 10. But you also can do nCr on your calculator. So if you go in here, there's like an options menu. So it's OPTN next to the shift button. And we can go in here across to prob. So it's the F6 arrow to go right, and then prob, and then nCr is right there. You've also got a factorial button too. So you need to put a number first. So it was 5 before it and then 3 after it. So 5C3 is the same as like C53 here. And you'll see this is 10. Now, this is another notation, 10C7. So 10C7. So I'm expecting the answer to be, let's say, 120. I don't know why there's 2 notations, but this literally just means C10-7. That's all it means. So we'll work it out by hand. So 7 factorial and 3 factorial. Notice the bottom 2 numbers add up to 10. That's how you know you've done it right. So it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Horrible. And then 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 3 factorial is 3 times 2 times 1. Now again, that would be a horrible, nasty thing to calculate, except for the 7 factorial cancels off with the 7 factorial, and then the whole thing's really simple. We can do a little bit of extra cancellations. So maybe the 3 and the 9, you'll be left with 3 there, and the 2 and the 8, you'll be left with 4. So I've got essentially 10 times 3 times 4 on the top, and nothing on the bottom, which is 120. So that's how you do it. If you want, you can just use your calculator. You can always do C and then whatever the number is there. And as long as this number is smaller than n or equal to n, you should be fine. And remember, if you're dealing with these, 0 factorial does equal 1. That's a little thing that should help you out a lot. Okay, now you might be wondering, why does nCr actually matter? And the point is for answering questions like this. So we have in previous videos done where the order matters. So we already know how to do this. We would have a team of 3 and we would have 5 people to choose from. You choose from 5, you've used up 1, so you got 4, and you've used up 1 more, so you got 3. So there would be 60 ways to make this team. But with nCr, we're doing order doesn't matter. I'll explain a bit more about what I mean by that in a sec. But I'm actually just going to list out all the teams. So we can have Alice, Bob, and Cass. That's one team. I can have Alice, Bob, and Dan. I can have Alice, Bob, and Eve. I could have Alice, Cass, and Bob, but that is actually a repeat of the first one, ABC. It's literally the same team, Alice, Cass, and Bob, because it's the same 3 people. So we don't count that one. And that's why when order doesn't matter, you're going to have a lot less ways to do this. All right, a few more. Alice, C and D. I've forgotten the names. Alice, C and E. Alice, D and E. And you'll notice my little strategy here. I'm keeping in alphabetical order so that I know I'm not going to get any repeats where it's just like shuffled versions. Let's see. There's Bob, Cass, and Dan. There's B, C, and E. And there's B, D, and E. That's all the B's. And there's also C, D, and E. And that should be all the teams. Now, let's count them up. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 ways if the order doesn't matter. And there are 60 ways if the order does matter. Okay, so you don't want to sit here and do this every single time. That's going to take you a really long time. So the way that you get this 10 without listing them out is you have 5 players and 3 choices. The C in nCr sometimes stands for choice. How do I choose 3 out of 5? So what we're going to do is C5, 3. Now, if we do that on a calculator, 5 and then nCr and then 3 does give us 10. So that is how we can get that number without listing. And that's what I want you to do for these questions. If it's a small number, you should list them out and make sure you got it right. And really important, the difference between if order doesn't matter versus if order matters. You'll notice that with something like, let's go ABE, there's a few different rearrangements. AEB, there's BAE, BEA, and then there's EAB and EBA. And then also the original one. So you'll notice that for each one, there's 6 different ways you can rearrange it. And that's why for each of these 10 ways, if you make order matter, then it blows up to 60 ways. Because there's like each of those 10 give you 6 rearrangements. And if you look at the formula, this formula here is 5 factorial over, I think, 3 factorial. Like that. No, 5 factorial over 2 factorial. That's my bad. And then this formula here, the way you work it out is 5 factorial over 2 factorial times 3 factorial. So that extra bit is dividing by 6 because it cuts out the duplicates. Okay. Now, how many teams can be made if Alice must be included? So the way that we answer this is, well, I can actually tell you instantly. The answer is, let's see, if Alice must be included, it appears to be 6 teams with Alice included. So I'm expecting that to be the answer. But we'll pretend we didn't know that. I'm going to put Alice first because it doesn't matter what spot she's in because order doesn't matter. And then there's going to be some mystery players, Alice and 2 mystery ones. This is C11. I've got 1 spot and I've got 1 person to choose from. It's Alice. And then here I've got C. Well, there's 4 people left and there's 2 spots. So C42. And we can see what that's going to give us. So C11. So 1 nCr and 1. How many ways do I choose 1 spot for 1 person? There is 1 way to do that. And how many ways can I fill 2 spots with 4 people? So for nCr2, there are 6 ways to do that. So it's 1 times 6, which is 6. Done. Okay, which matches what we got from the list. Now, Alice and Dan do not get along. So we don't want to team with Alice and Dan. So I can already tell you what the answer is in advance. So that one's fine, that one's fine, that one's not. ACE is fine, that one's not. And then anything without Alice should be fine as well. So out of the 10 ways, I'm missing 3. So I'm expecting the answer here to be 7. But the way you can do this formally without actually listing it out is we can go Alice, but no Dan. Dan deserves a capital letter. Sorry, Dan. Dan, but with no Alice. Okay. So the way that you sort of do this is you put Alice in the team, and then this is C. There's only 3 people to choose from now because Dan can't be in there, and Alice is already used up. So it's C11 times C32. And then here you can go Dan in the team, and then C32 there as well. So C11 times C32. Okay, so if we do that, C11 was 1, but 3C2 is 3. So there are 3 and 3. So in total, there are 6 possible teams that I can make. Now, I claimed there were 7, so this adds up to 6. There are 7. I really would encourage you to pause the video and see what team am I missing? What have I not accounted for? assuming you've paused and figured it out, I'm going to give it away now. It's the team with neither of them. So there are 3 spots, and it's 3 people and 3 spots. 3 people because you can't have Alice or Dan, and there are only 5. So C33, which happens to be 1. So this equals 1, and then the total is 7. So there we go. 3, 3, and 1 give us 7, and that's exactly what we got from actually listing out the teams. I really want to stress, in a real question, you will not be able to list out the teams because there's probably going to be like 100 things in your list, or maybe even more. This is just to illustrate that it works, right?